So let's move on to number 6. And number 6 has to be, like out of these 6 problems, obviously it's the most difficult one because it involves some combination, counting skills. So this question is basically you have a set of 1, 2, 3, 4, 5 again. And what happens is A and B are both subsets of this set. And when I say subset, it can be empty or it can be just equal, actually, to this whole set. The absolute value of the set, it means the number of values in this set. This symbol means the intersection of the two sets. This means the union of the two sets, and basically we're trying to find how many combinations of A and B are possible. So obviously there are a few cases that we can actually consider. The first case is that very simple. Both A and B are empty, and this is one case. Another case is when one of the set is empty. And why does one of the set is empty like this condition? How does this condition satisfy the equation above? So if, let's say without loss of generality, let's say A is let's say A is empty and B is a non-empty set. So what happens is the intersection of A and B is empty. So the whole thing becomes 0. So that's why, so let's say if A is empty without loss of generality, then there are a few choices, like B can be whatever it wants to be. So it have 1 element, 2 element, 3 element, 4 element, or 5 elements. So we have C51, 5C1 and 5C2 plus 5C3 all the way to 5C5. So we have 31, 2 to the power 5 minus 1, so 31. And it's also the same for when B is empty. So in this case, we have 62 in total. Now let's move on to some other cases. Another case that can happen is when A and B are completely equal, just equal subsets. And equal subsets as in like they're just equal, completely equal. So what happens is the intersection of A and B is just completely the same as the union, and also the same as A and B themselves. So in this case, we also have C51 plus C. There's no C50 because I already counted it as this empty. So we have 31 cases in this case. Now let's move on to some more. This is A equals to B. Now let's move on to some any other cases that can satisfy the equation. So apparently, I'm not gonna do it now because it's gonna be too long. So apparently during the exam, I found out that A has to be a subset of B, and you guys can think of the reason to why that is, because it's very because I did some very stupid method of verifying some numbers, and I found out that the intersection of A and B has to be it has to be equal to one of the A and B, and which means if that is true, that means one of them has to be a subset of another one. So let's say A is the subset of B first. Let's say A is a subset of B. So if A is a subset of B, then we can already have a lot of cases that we can do. So what happens is if the length of A is equal to 1, we have some cases to consider. So if we have these 5 numbers, and we choose one of the numbers, we can choose one of the numbers from it and make it A. And what happens is, how many choices do we have for B? Since A has to be a subset of B, what we can do is we have to make B a set that is greater than A, but also contains the elements of A. So what we can do is we only have 4 choices left because we have to choose the number A chose. So we have C41 plus C42. This is when B has 2 elements long, 3 elements long, 4 elements long, and 5 elements long. So in this case, we have 2 to the power 4 minus 1 times 5. And this is 100, this is 75. And since it can be reversed, so the same as when B is subset A, B is a subset of A, so 75 times 2. Or if you prefer, you can do times everything by 2 at the end. But I prefer to do it this way because it's more tidier. So when A has 2 elements, it's the same thing essentially. We have 2 choices for A and only 3 choices left for B. By the same logic, we can continue to do all the rest of the problems. When A is equal to 3, then C53 times C21 plus C22. That's, let's see, that's 30. So 30 times 2 is 60. And finally, at the end, we have A equals to 4. So that's only C54 and just C11, that's it. And 5 times 2 is 10. And when A is equal to 5, when it has 5 elements, it doesn't apply because if A has 5 elements and it has to be a subset of B, then B also has to have 5 elements. And this means that A has to be equal to B. And we already counted that case, so we're just going to ignore it for now. And in fact, we're actually done with this problem. We just have to add up all the numbers. So 150 plus 140 plus 60 plus 10. And if we go back to the page before, we have 1, which is when 2 of them are empty. We have 31 when all of them are equal. And we have 62, which is when one of them is empty and the other one is not. If we add this up, this is 454, and that is the answer to this problem. Yeah, so I would say in general, overall, I thought this test is very difficult because it's the Aime Ii, and it's also my first time joining the Aime Ii, so I really don't have a lot of experience. Maybe if you're an experienced, mathlete, you may think, oh, the way I do problems are really stupid. But I gave my best for this competition, and this is so far I got for Aime Ii. So I'm very happy that I can share my solutions with you, and I hope you guys enjoy this video, and we will see you soon.